And this is Honors Geo 4445, side angle side, hypotenuse leg, side, side, side. So, we already said in a previous section that we can prove triangles congruent by saying that all corresponding angles and all corresponding sides are congruent. Then we can say the two triangles are congruent. Now we can add theorems and postulates to it to say that various triangles are congruent. And one of the postulates that we have is something called side, side, side. So we go SSS postulate. And what side, side, side postulate says is that if three sides of one triangle are congruent to three sides of a second triangle, then those two triangles are congruent. So here we have three sides, A congruent to, or AB congruent to RS, BC congruent to ST, and RT congruent to AC. RT congruent to CA. And then we can say that since the three corresponding sides are congruent, that ABC is congruent to RST. Three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. And we have examples of side, side, side here. We have this triangle, and they tell me that KL is congruent to LN, KM is congruent to MN. Prove that the triangle KLM is congruent to triangle NLM. Well, I can use the reflexive property and say that LM is congruent to LM. Then I can say that these two triangles are congruent because it's side, side, side. So the first step would be my given as a proof. We have all that stuff. K L is congruent to NL. KM is congruent to NM. And since I have that one side that's shared by both triangles, I can say that it's congruent to itself. Reflexive property. Therefore, I can say triangle KLM is congruent to triangle NLM. Side, side, side. Now we gotta see if they're true and why. Well, this is true. We have three sides congruent to one triangle to the next. DG is congruent to HG. JK is congruent to FG. FD is congruent to JH. So that is true. Here we have BC and AD congruent. We have AB and DC not congruent. And AC is congruent to itself. So this is not two congruent triangles. So we can't use side, side, side. Here, TR is congruent to TQ. PT is congruent to ST, and then SR is congruent to PQ. So this is congruent under side, side, side. So number one, yes. Number two, no. Number three, yes. I can also use the distance formula of triangles in a coordinate plane to see if all their sides are congruent. And if the sides are congruent using the distance formula, then you can say that they're congruent triangles using side, side, side. Okay, so that's section 4.4.5. We have two theorems. We have side angle side theorem And what side angle side theorem says is that if two sides of an included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the two triangles are congruent. So what does that mean by included? So here is a triangle. We have this guy here. We have another triangle. And what it means by included is that the angle has to be in between the two corresponding congruent sides. So this would be the included angle because it's in between the two sides that are congruent to each other. While the other angles here would be excluded because it is not in between the two corresponding sides that are congruent. So this is congruent to that, that's congruent to that. This is the angle that's in between the two corresponding congruent sides, therefore they would be considered included angles. So looking at the postulate, this is a postulate. If two sides of an included angle of one triangle are congruent to two sides of an included angle of the second, then the two triangles are congruent. That is side angle side. So in the case of this guy in the proof, we have BC parallel to AD. We have this triangle which is like a transversal, so parallel lines and transversals, they don't go away. I can say that angle BCA is congruent to angle CAD here. So let me draw this. Let me draw this. Okay. Okay. B C A D. We're told that these two guys are congruent. We're also told that these two guys are parallel. Do I have enough to use side angle side? Well, I can say that AC is reflexive and congruent to itself. Since this is two parallel lines and this is a transversal, if I were to expand it out, hopefully you guys are getting better at seeing parallel lines and transversals now. I can use alternate interior angle theories and I can say that this guy is congruent to that guy. And the reason why I'm using these two guys is because it's the included angle between these two corresponding congruent sides. So I want to use these two. So I have enough angles. I have enough information. Side angle side, side angle side. So I can use side angle side to prove these guys congruent. And here's the proof. Given, I don't know why they did it twice, but you can write it in one step. Then I can say that angle BCA is congruent to angle DAC or CAD. Alternate interior angles theorem. Then I can say that CA is congruent to itself. Then I can say that the two triangles are congruent. So ABC is congruent to CDA. That's side angle side. Alright, so this one says a lot. There's a lot of stuff in these two proofs. We have a a square within a square. Oh, that doesn't look accurate at all, but oh well. We're told a couple of things. We're told that the square on the outside, ABCD, has 4 congruent sides. So all of these sides are congruent. This is congruent. That's congruent. That's congruent. That's congruent. We're told that we have 4 right angles here at here, here, and here because we're told it's a square. We're also told that this guy is the midpoint, so we have this guy, this guy, this guy, this guy, this guy, this guy. Lots of little parts. Okay? Actually, I'm going to put this in blue so that we can tell the difference. So the whole side here are congruent, and then the little sides in between are congruent. Then we're also told that RT is perpendicular to RS. So all these guys are perpendicular. It's a lot of information. So the first thing I wanted to prove is SVR. Where is V? Oh, V is right here. Oh, Lord. I'm going to put a dot there. I'm going to put a dot here to say that that's V. Alright. Alright, so they want us to prove that SVR is congruent to that guy. So, here's S, V, and R. And then here is U, V, and T. S, V, R, U, V, R. Okay. So both of these, so if I was to draw this out over here and superimpose, here's SVR and here's URT. Okay, so UVR. UVR and SVR. So things that I already know. I can say, I know that these guys are perpendicular. Because it's perpendicular intersection. They share this side here, so I know that this guy is congruent to itself. I'm also told that SV is congruent to UV, so I know that this guy is congruent to that guy. So I have enough information to say that these two triangles are congruent through side angle side. So I'm not going to write all of that stuff down for the givens because that's a whole bunch of stuff. So we have our given. Next thing I can say is that I'll say that these guys are perpendicular. I can say that angle SVR and angle UVR are right angles. And that's a definition of perpendicular lines. So since they're perpendicular, then they're right angles and they're congruent. So I can say that angle SVR is congruent to angle UVR. And I can say that right angle congruence theorem. Right angle congruence theorem. It's already given to me that these two guys are congruent. So I just have to say that RV is congruent to itself. Because of reflexive property. Okay, and I have enough information to say that the triangles are congruent. So SVR is congruent to UVR. Side angle side. Okay, so that's that one. Number 2 is a really, really long proof. And I think I'll do that one in another lifetime. I don't think you can get by without the second one. It might be a homework question. That's how good it is. Okay, so we have another one. Called hypotenuse leg, but they talk about included and not included. So this A and A here is not included because it's not in between the two congruent corresponding sides. So we talked about that. And now we have hypotenuse leg. This is only for right triangles. So a right triangle is a triangle with 190-degree angle. And these guys on the side here is called a leg. The side that's opposite of the 90-degree angle, so here's 90 degrees, this guy is directly across from it, directly opposite of it, is called the hypotenuse. Alright, so we have another theory called the hypotenuse leg, and this only works for triangles. Right triangles. And it says that if the hypotenuse and leg of one right triangle is congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. Hypotenuse leg. If the hypotenuse and leg of one right triangle is congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. Hypotenuse leg. Okay. Here's a proof using hypotenuse leg. We're given that WY is congruent to XZ. We're told that WZ is perpendicular to XY, and XY is perpendicular to ZY. Prove that they're congruent. So it's given those things. So we know Z and Y are right angles, per definition of perpendicular lines. And that's all we have to say. We don't have to say that they're congruent because we just proven that they're right triangles. The next one, definition of a right triangle, because we have one right angles each. We can say here that ZY is congruent to itself because they both share it. Reflexive property. So now we have a leg here. We have the hypotenuse here. We have the same leg and a hypotenuse, and then we have the right angle. Therefore, we can use hypotenuse leg. Here, the same thing for this guy. We have a triangle that's right. We have another triangle over here. This is A, B, D, and C. This is a right angle. This is a right angle. This is the hypotenuse on both sides. And then I can say that since they both share this guy, that's the leg. So that's the thought process behind this one. I'm not going to redraw ABC side by side. That makes no sense to me to draw side by side. Keep it just like this. So doing number 3, let's prove it. That's weird. I can say I have my givens would be that AC is congruent to BD. And I can say that angle B and angle C are right angles. Because it's given. Because it's given to me. Alright, so I have the hypotenuse of the leg. I can say that BC is congruent to itself. And BC is congruent to itself because of the reflexive property. So now I have the hypotenuse congruent to each other, and I have the same leg congruent to each other, so I can say, lastly, that triangle ACB is congruent to triangle DCB, hypotenuse leg. Okay, so that's this section. I hope you have a great rest of your day.